5A to do 5B. But 5B, the difference with 5B is that it has a different question. Okay. So for 5B, we're still using the same triangle. So I drew the triangle. All the same data is the same. So anything, so it says how fast is the area of that triangle changing when the bottom is 15. So if the bottom is 15, the ladder is still 25 feet. Okay. So that means the wall has to be 20 feet. So first thing we got to do, label everything that you know. Okay. So from the last question, we know a couple things too. Besides the sides and the hypotenuse, we know dy dx, or sorry, dx dt, right? We know that x is being pulled away at 3 seconds, right? So that's what gave us this. So we're still going to use that. Dx dt. Three feet per second. We actually know dy dt now because that's what we solved for on the last problem. It was negative 9/4 feet per second. And what was dz dt? 0, yeah, because that's the feet per second. That's dz, or side z is the ladder, right? And the ladder can't get any bigger or smaller. It's the ladder. That's how long it is. So that side's not going to change. The yellow side will not change. It won't get any wider, or it won't get any longer or smaller. Okay, but as the red dot, right? As that red dot comes down, that's going to make the bottom get bigger and the wall get smaller. Okay. All right. So that's all the info from the last question. What is the question asking, though? So we got all that stuff, which is great. What is the question asking? So the area of the triangle, right? So they want to know the area, or they want to know a rate of the area? Rate, right? So area is capital A, right? So if we want to find area, capital A. But that's not what they want, right? They want the rate of the area. So how do we rate that? D capital A over dt, right? That's what we're trying to find. Okay. So now that was step 2. So step 1 was list everything we know. Step 2 was list what we don't know, what we're trying to find. Step 3 is what equation relates everything together. So relates what we're trying to find with what we have. What equation or formula would we use? The area of a triangle, right? Area of a triangle, 1/2 base times height. I don't want to use base and height because in mine I use x and y, right? So in mine it would be x, 1/2 x times y, or x times y divided by 2. Okay. They asked me about area. That has area. It also has x and y, which I know already. Makes sense, right? I'm not going to use, it didn't ask anything about z, like hypotenuse. There's nothing in there by hypotenuse. So I wouldn't use Pythagorean theorem on this one. The one before, absolutely, but this one, no. Okay, so the next thing I need to do is find the derivative of that guy. Okay, so the derivative of capital A, what's the derivative of capital A? So it'd be 1, right? D capital A over dt. Because it's 1a. How would I find the derivative of 1/2 xy? How would I find the derivative of this guy here? I'd have to use the product rule because x and y are two different things and they're being multiplied together. So the 1/2 is multiplied times everything. So I'm going to put 1/2 in the front. So whatever I get as the derivative, then I'm going to distribute 1/2. Okay, so for this guy here, product rule says the first times the derivative of the second. The derivative of y is dy dt plus the second times the derivative of the first, dx dt. Okay, so we came up with our formula. We found the derivative of our formula. The last step is plug in what we need to know. Plug in what we don't. Plug in what we know. I don't know d capital AT over dt. I don't know that. So that one's still going to be there. So 1/2 times, I know x. X is 15. I know dy dt. That's negative 9/4. I know y, 20. And I know dx dt, 3. So now I have enough information where I can figure out the rest. So let's see. 15 times negative 9/4. 15 times 10 is 150. So 135. So negative 135 over 4 plus 60. That's 15 over 1. Okay, so now I can distribute the 1/2. So it's going to be negative 135 over 8 plus half of 60 is just 30. Now all that's left to do is just add them together. So if they have a denominator of 8, so instead of 30, 30 is the same as 248. So add those together and we get positive 105 eighths. I don't think it can be reduced. It's going to be a 12 or 13 around there. Okay. That's how fast it's increasing. That's how fast the area is increasing. So the last step is what units would we use? What units would we use for this guy? Say it again. Not cubed because it's area. We use cubed for volume, which we'll do later, but not for this one. So it'd be feet squared still, but it's a rate per second. Yeah. Anything volume, we use cubed. Anything area, we use squared. If it's a rate, just make sure it's over time, some sort of time. Okay. All right. So now let's look at number 6. So number 6, now we're going to get to three-dimensional objects. It's the same thing. I'm not changing any of the rules. It's the same thing. The only difference is instead of a two-dimensional triangle or a rectangle, it's a three-dimensional shape, a sphere. But it doesn't change anything. You're still going to use the same steps we used. Okay? We're just dealing with volume sometimes. Okay? So our first step is to read the question, write down what we know. Okay? So read the question, underline, circle, write down what we know. So the radius of a sphere is increasing at a constant rate of 2 meters per second. At the instant when the radius of the sphere is 5 meters, what is the rate of change of volume? And then they give us the volume equation. When they give you an equation, more than likely, that's the formula we're going to use. On step 3, that's the formula we're going to use. Okay, so sometimes they give you that. And then it says round your answer. So this is a calculator question. We can use calculators. Okay? Okay, so let's write down what we know. So I kind of drew a rough picture. It's kind of a sphere, right? A sphere is just like a tennis ball, basketball, right? The radius is from the center to an edge. So the center of the baseball, softball, or basketball to the edge. Okay? So what do we know about it? What do we know about this sphere? The radius is 5 meters. So let's say R is 5 meters. 5m. Good. We know that. What else do we know? The radius is increasing at 2 meters per second. So positive 2 meters per second, right? How do we write? What is it going to be on the other side? What is equal to that? What symbol are we going to use for that? What symbol would we use for this? dr over dt. The radius is changing over time, right? That's a rate. Okay. Good. Do we know anything else? Anything else that we know? We know the formula, right? They gave us the formula. This is the formula for volume of a sphere. Okay, so if that's all we know, that's all we know. Sometimes they give you a lot, sometimes they give you a little. Okay, so now what do we need to find out? What's the question asking? It's asking about volume. So is it asking the volume or is it asking about volume? It's about volume, right? It's saying the question asks, let me find out exactly what it says. What is the rate of change of the volume? How do we write that as a symbol? dV, d capital V over T, yep. Because they don't ask us what the volume is. We could find the volume. I could plug in 5 for R and get the volume. I might need to do that later. But they don't really need to know, we don't really need to know what the volume is right now. If, like I said, if we need to find the volume, just plug in 5 for here, and you got the volume. Okay. So that's everything we know, everything we need to know. Now, they've given us the equation or the formula. So this is the guy we're going to use. Volume of a sphere. Now I got to find the derivative of that with respect to time. Okay. So what's the derivative of V? dV dt. dV, yeah, d capital V over dt. Good. Here's kind of a trick question. How would I find the derivative of 4/3 pi r cubed? Yeah, a lot of times people see this part right here and they're like, oh, you're going to use the product rule. Do I need to use the product rule for that? No, because that's a number. Yeah, that's a variable. That guy's a variable. Or sorry, a number. R is the only variable that I have. Okay? So I could just use the regular power rule. Just move the power to the front. So move the power to the front. So 3 times 4/3 pi. Subtract the power. But I did find the derivative of R. So I need a dr dt. I need a tag. I need a dr dt tag. Yeah. Three over 1 times 4/3 is just 4. So really the derivative is 4 pi r squared times dr dt. Okay. Plug in. I don't know dV dt because that's what I'm trying to find. 4 times pi times r squared times dr dt. R is 5. Dr dt is 2. So 5 squared is 25. 25 times 2 is 50. 50 times 4 is 200. So 200 pi. Now that works, but it does say round your answer to the nearest decimal. So that means they want us to actually multiply times pi, not just leave it like that. Sometimes they want you to leave it like that. If it's a non-calculator question, leave it like that. But since they want you to round your answer, we're just going to multiply times pi. So 200 pi, 628, and then they want us to round to the nearest 3 decimal places. So 628.319. 0.319. Last step, give that how would we label that? What would be the units for this guy here? That would be cubed, right? So we're talking meters cubed. Was it a volume or was it the rate of a volume? So it's going to be over seconds, yeah. If it's just regular volume, it's just meters cubed. But if it's a rate of a volume, then it's meters cubed over time. Okay. So what I want you to do now is I want to give you a chance to do one on your own. It's a shape we haven't used before. It's a circle. So the two formulas that are big with circles, one is area of a circle, area equals pi r squared. The other is circumference of a circle. Circumference is the distance around the circle. That's 2 pi r. So what I want you to do is solve this one. You're going to use one of those formulas. You're not going to use both of them. You're going to use one of them. Use the one that you need. If it talks about circumference, you're going to use circumference. If it talks about area, you're going to use the area one. Okay? So I want you to do this one and see what you come up with. Okay? So I wrote down everything I know. And I'm trying to find the rate of change of the radius. And then I'm going to use the volume formula since they gave it to me. Again, I'm going to have to use the product rule for this one, though, because R and H are variables. Okay, so the derivative of V is dV over dt. Pi is a constant, so I'm just going to put pi in the front. Whatever derivative I get, I'm going to multiply times pi. So the derivative, so the first, which is r squared, times the derivative of the second. The derivative of h is dh over dt, plus the opposite. The derivative of r squared, 2r, dr dt, times h. Plug in what I know. dv dt I know is 0. So this guy is going to be 0. I know it has to equal 0 because the can is not getting any bigger. R is 5, so 5 squared. dh dt was negative 5. 2r, 5. dr dt was we don't know. So dr dt is going to be our guy that stays, times h. H, ooh, do we know h? We don't know h. Can I figure out what h is? Do I have enough information to figure out what h is? Where do we see h? Where do you see h? I see a couple times. Where do you see the letter h? See it right here, right? Where else do you see it? Right there. I don't know h. Do I know r? Do I know v? I can solve for h, right? I can solve for h. So that's what I'm going to have to do. I'm going to have to solve for h real quick so that I can plug it in. Volume is 162. Pi. R is 5. H is, I don't know. Okay. So 5 squared is 125, or sorry, 5 squared is 25. Divide by what I don't want, or what I already know. I already know 25 pi, so I'm going to divide by 25 pi. So I get h equals 162 over 25 pi. Do not round that number. The only time we round is our answer. That's not our answer, right? That's not our answer. We're not there yet. The only thing we round is our answer. Because if you start rounding early, you're going to be way off. Don't round until you get your answer. All I'm going to do with that guy is I'm going to plug it in for h over here. I'm going to plug it in for h. 162 over 25 pi. Okay, because a lot of times people try to round that number and then plug it in. You don't want to round until the very end, because otherwise, especially if it's a multiple choice question, your answer is going to be way off from any of the A, B, C, Ds. Okay? Okay, so now let me clean this up. So we get pi 25 times -5 plus 10 times 162 over 25 pi times dr over dt equals 0. Okay. Pi 25 times 5 is, or -5 is 1 negative 125. I can reduce these guys by 5. So what do I get? 324 over 5 pi. Distribute. Negative 125 pi plus, the pi's are going to cancel out. So when I distribute a pi, it's going to be 324 pi over 5 pi. Those pi's will cancel out. So 324 over 5 times dr dt. So now we're going to get dr dt by itself. So I'm going to add 125 pi to both sides. (324 over 5 times dr dt. Divide both sides by the fraction. Well, when you're dividing fractions, you're just multiplying by reciprocals. So multiply both sides by the reciprocal. So we get dr dt equals. Now we can put it in our calculator. That's going to be our answer. So once you're going to get your answer, then you can put it in your calculator. So 5 over 324 times 125 pi over 1. See, 324 divided by 5 times 125 pi. Oops. You can say divided by 1. You don't need divided by 1. What did I do something wrong? Oh, sorry, it's the other way around, right? Should be 5 on the top, right? And 324 on the bottom. There we go. 6.060. 6.060. It's a radius, so it's going to be centimeters per second because it's a rate of a radius. And you're good. The radius is getting bigger by approximately 6 centimeters per second. So the next question, number 9, is very similar to number 7. The only difference is you're going to use circumference because it's asking about the circumference. So actually, you know what? Let's do this one. Let's do this one, and then we'll finish tomorrow. All right, so right now what I want you to do is write down everything you know. Everything you know, what are we trying to figure out? Okay, so what do we know about this circle? What do we know about this guy?
The area of the circle is decreasing at a rate of 1 square feet per second.
The area is increasing, is decreasing. Sorry, yeah, so it's going to be negative. Good. What tag am I going to give that guy? No. dA over dt, yeah. D capital A over dt, good. The area is increasing because it's a rate of, good. Okay. What else do we know? Area is 9 pi. That's feet squared. Because it's not a rate, it's just the area. Good. Is there anything else that we know? I don't think so. What's the question asking? So they're asking for d capital C over dt. That's what they're asking for, right? If they're asking for that, the only way to find that is by having a C. So the circumference of a circle is just how far. If I were to walk all the way around this circle here, if I were to walk all the way around this circle, how far would I go? That's what the circumference is, okay? So area is how much paint do I need to paint the inside of the circle? How much paint would I need to paint all the inside of the circle? That's area. Circumference is if I walk around. So if I were to walk around the track, that's the circumference of the track when you walk around it, okay? That area, circumference of a circle is 2 pi r. That's the area, that's the formula for that. So that's the one we're going to use because we need circumference. I know about area. I know area, but I need to figure out circumference. So that's the one I'm going to use. Okay? Okay, so got to find the derivative of that guy. So d capital C over dt. Luckily, this guy's only got one variable, r. And the power is just 1. So it's going to be 2 pi. R is gone since r loses the power. And it's going to be dr over dt. Okay. Plug in what we know. I don't know dr dt, though. I don't even know anything about the radius, right? So circumference doesn't have, So what I'm going to do is I'm going to have to find r first. Do I have enough information to find r? I do, right? How am I going to do that? What am I going to have to use to find R?
equation of area.
Area, right? I know the area. I just don't know what R is. I got to solve for R. So get R by itself, divide by pi. 9 equals R squared. So what is R going to be? 3. We don't have to worry about -3 because it's length. So R is 3. Is that going to help us? Are we there yet to find dr dt? No, we're not there. So remember when I talked about that that step that we didn't need to do for the first, that step, what was it, step 4 of the original? I said skip step 4, we'll do it tomorrow. Now we're going to need to do it. So what we need is another equation or another formula. Another equation or formula that'll help us get to where we need to go. I need dr dt. Where would I get dr dt from? Where's the only place I would get dr dt from? The derivative of the area equation, right? So that's what I'm going to need to do. I already did that, though. You guys already did that, right? You guys already found derivative of this guy on another problem. It was 2 pi r dr dt, right? That's the only place I can find dr dt. If they don't tell me what it is, it's the only place I'm going to find it. So it seems like all that other information they gave us at the beginning kind of was extra. Now we ended up needing it. So this is going to be -135, 2 pi. R we know now is 3, dr dt. So -135 equals 6 pi dr dt. Divide by 6 pi. When you divide, don't divide on your calculator because this isn't our final answer. We're just using this because we need dr dt. So dr dt is going to be -135 over 6 pi. Now we're going to go plug that guy in over here. That's the only time you need to use a second equation, second formula. Sometimes you need to use a second formula when you don't have enough information, when you don't have something, then you got to use the second formula. So this guy I can put in my calculator because this is going to be my final answer. This guy, it says it's okay to round. So I'm going to go put that guy in my formula, in my calculator. So 2 pi parentheses -135 over 6 pi. And we happen to get an answer, -45. Okay. So that means the circumference is actually decreasing. Circumference is a distance, so it's not a squared or a cubed. So what would it be? Feet per second. Okay. All right. Okay, we got a couple more.